So once again, there's a few people who have said they're new. Welcome to all of you, and I hope you have a great time. How it works is that we go through content for the evening. I'm going to be teaching, and I'm going to be giving you lots of chance to practice and answer questions. And then at the end of this lesson, we'll be doing a poll. On a Thursday evening, which is coming up this week, we will be doing a quiz on what we learned this week. So I hope to see you back here on Thursday for that. Okay, we've got some shout outs. Speaking of quizzes, we've got 3 people who did very well on their quiz last week. Sipisichle, I don't know if she's here this evening, and Iazia and Cassandra, you all did well last week on your quiz. Top 3 marks in the class. Well done on that. And I hope to see some new names up here next week as we do our quiz on Thursday. Okay. Well done to those guys, and now we're going to jump right into our lesson. Today it's on simple trig equations. Oh, there's Sipe, well done. It's good to know you're here and that you heard your shout out. Well done. Okay, so today we're going to do some trig equations, and for that you are going to need your calculator. So you should have a calculator like this one, which is the Casio. And I've got the silver one, but if you have a blue one or a pink one, that is fine too. And we're just going to start by solving some very simple trig equations this evening. And so if we have, and let's look at this first one, if we have tan of p is 0.684, so basically that says what angle, if I take tan of a certain angle, I get 0.684. And if you guys can just give me a second, I'm just plugging in my pen here. There we go. So on our calculator, we go shift tan 0.684, and that gives me that P is 34.37 degrees. Okay, you should have a pen and paper and your calculator with you and work with me as we go. So the next one, we've got sine of 3a is equal to 0.821. So this one is slightly different, because now we have 3a, not just a p like we had in the first one. So again, we're going to go shift sine and 0.821 on the calculator, and then we get 55.19, but this time 3a is 55.19. So if we want to know how much, if 3a is 55.19, then a will be, and we divide by 3, then we get 18, and I'm rounding to 2 decimal places. So if I get 18.395 on my calculator, then I can round that to 18.40. Okay, so the important thing to note here is that we don't divide by the 3 at the start. We only divide by it at the end. Okay. Right, let's have a look at this next one. Sorry, can I just ask that if you are having technical issues, please send a direct message to Ms. Coco, just so that we can keep the chat clear for questions and answers. That will just help those who want to send through anything. Okay, so the next one, we've got 2 cos theta minus 10 equals 1.268. So the first thing we need to do here, and here is my little reminder that I wrote here for you. The standard form of a trig equation is always trig ratio angle equals your value. So we have to start here by dividing by 2. That gives me cos theta minus 10 degrees. And we divide the 1.268 by 2. And that gives me 0.634. Okay, we can't go any further. We go to our calculator and find what the angle is. So in this case, it's theta minus 10 is my angle. And I go shift cos of 0.634. And that should give you 50.65 degrees. But I need theta, not theta minus 10. So to fix this, I'll put plus 10 on both sides. So then theta is 60.65 degrees. Okay, so that's some basic equations that you probably encountered in grade 11 and grade 10. We are going to run through them relatively quickly, but also take our time to make sure, because remember, this is trig foundations. So we want to make sure we've got our foundation in place so that you are ready for the trig in grade 12. So I've got on the screen there 3 questions for you to do. Please start them now. I'm going to give you, let's say, 5 minutes to do them. As soon as you're ready, put your answers in the chat and we'll see how we go. Can I just first get a thumbs up or a thumbs down to see how everyone's feeling about this? How are we doing so far? Please put it in the chat so that we can see if you are feeling good about this. Thumbs up. Wonderful. Great stuff. Okay, off you go and do those 3 questions. Good stuff. Lots of thumbs up. Thanks for those who've posted answers already. I think let's hold our answers until we've done all 3. So when you have done all 3, put all 3 your answers into the chat all at once. Okay, so there's about 2 minutes left. Right, okay. Lots of answers coming in, and it seems like there's some disagreement about the answer for question 3. But let's have a look. So for question 1, you should have had 13,53. I think most of you got that one right. And then for question 2, 34.45. I think most of you got that one as well. 34.45. Yeah, if I scroll through quickly, yeah, I think most people got that one as well. But let's have a look at question 3 that seems to maybe have people a little bit stumped. I do see a few new people have joined us as well. So welcome, and we are busy solving some very simple trig equations just to refresh our memories of how this works. Okay, so we first need to probably get rid of the quarter that's in front of sine A. Remember, we always go back to this principle here that the trig ratio and the angle must equal a value. So no number or anything in front of the trig ratio. Well, there is a number, it's 1, but we basically first do that. So if it's a quarter, to get rid of that, we are going to times by 4, because a quarter times by 4 just gives me 1. But what I do on one side of the equation, I must also do on the other side of the equation. So that's going to give me sine 2a plus 20 degrees equals 4 times 0.214, and that is 0.856. Okay, now we're at a point where we have our trig ratio equal to a number. So we go to our calculator and we say shift sign, and we get 2a. So our angle here, 2a plus 20 is equal to 58.87. But we still need to get the angle by itself. So we're going to subtract 20 on both sides. So that gives me 2a is, so 58.87 minus 20 is going to give me 38.87. And if 2a is 38.87, we divide by 2 to get a by itself. So our final answer is 19.44 degrees. Okay, I think some people got this one. If you didn't get that, make sure you understand about getting your trig ratio by itself. If there's numbers with the angle, you only do that at the end. Okay, so when it's trig ratio equal to a number, if it's in that format, then you carry on and you do your reference angle or just your angle using your calculator, and then you get your variable by itself. Okay. You can also divide both sides by a quarter. It's the same as multiplying by 4. You should have gotten the same answer, Solomon. That will work too. Okay, so that's our basic ideas around a trig equation. So let's move on to something a little bit more interesting and advanced. So let's say we've got sine theta equals to 0.5, and I just want everyone to go on their calculator, shift sine 0.5, and that should give me that theta is 30 degrees. So theta here is 30 degrees. Okay, so if I go to my sine graph over here, so I've said here, think about your sine graph, this one over here. And if you go to a half, which is on the y-axis, then that will be 30 degrees. But because the sine graph makes this wave, it will not only be a half where x is 30, it will also be a half at this point here, 150. And if you don't believe me, you can go on your calculator and say sine of 150 degrees, and you should get a half. Please check that now. I just want to make sure that everyone is with me with that. So if you say sine 150 degrees,
you guys can give us a thumbs up if you get, I'm sure it's the correct answer, ma'am. So everybody should give us a thumbs up for this one.
0.5. Okay. Good stuff. Yes. Okay, wonderful. So everyone's getting that. And just for interest's sake, actually, you can also go let's not do that. Let's not jump ahead. Let's stick with the plan. So basically what you notice here is that more than one angle can take the value of 0.5. And when we find the 30 degrees, that is the acute angle in the first quadrant, basically. Remember a few lessons back, we looked at the quadrants, and I'll draw it here quickly just to remind you, but 30 degrees will definitely be in this quadrant. But there are more than one angle that can equal a half for sine because of the pattern that it makes and the fact that it's a wave and that it repeats. So the reference angle, or this 30 degrees, is the acute angle in the first quadrant, and we use that angle to find all the other angles in all the other quadrants. Okay, so let me explain further. So if we want to know in the second quadrant, remember the second quadrant is 180 minus theta. And if I go 180 minus 30 degrees, guess what I get? 150 degrees. Okay, so for that reason, we have to not only give that first angle, the acute angle, but also the other options. And for today's lesson, we're going to just work between 0 and 360. So let's have a look at this first one. Cos of x is 0,279. And let's work together on this first one. So if cos of x is 0,279, let's get our calculator and then let's find the first angle that is going to equal, that will give us 0,279. So we go shift cos 0.279. And pop your answer in the chat when you are done. Yeah, 2 decimal places. Please round to 2 decimal places. Okay, so that's our first angle that can give us 0.279. So to get the next angle in the interval 0 to 370 degrees, okay, so that's what we're doing. We're now not just finding this first angle, but we're finding all the angles between 0 and 360 that will give us 0.279. And for that, we go to our Cartesian plane and we look at our quadrants. And where is cos positive? Because this ratio, 0.279, is positive. And cos is positive in the first quadrant and in the fourth quadrant. Because of SOHCAHTOA, no, not SOHCAHTOA, all stations to Cape Town, all stations to Cape Town, or whatever other way you've got to remember it. But that's from a few lessons back when we did this as well. So this quadrant is 360 minus. So we're going to subtract that acute angle from it. Yes, cast or act, that's fine, yes. So we're going to subtract the 73,80 from it. And then we get our second angle that will give us 0.279. So 360 minus 73.80. That gives me, pop your answer in the chat if you've done it. 360 minus 73.80. That gives me, waiting for everyone to put their answer in the chat. 28.60. 28, that's right. Okay, so it's 286,20. And let's double check. Let's now go on the calculator and say cos of 286.20. And you should get 0,279. Okay. Right, let's have a look at number 2. So with number 2, we got some thumbs up in the chat. Wonderful, guys. Okay, so now what happens if this ratio is actually negative? If the number we are working with is actually negative? Okay, we are going to, in this case, ignore the negative when we find the angle. Okay, so on our calculator, we are still going to put in what is shift sign 0.279. So ignore the negative. When you are finding the reference angle. So this acute angle that we find is called the reference angle. It's the first value that we get that takes on this number. Okay, so I see lots of 16.2. So let's go shift sign 0.279. I also get 16.2. So we can say our reference angle is 16.20. Okay. But now what about that negative? We can't just throw it away or ignore it. We are going to use that negative to do our quadrants. So in which quadrants will sign be negative? In which quadrants will sign be negative? Pop your answer in the chat if you know. Second and third. Thanks, Jared. You were first to get there. Second and third, sign is not negative in the second and the third. Sign is negative, yes, in the third and the fourth. Okay. So to find our answers then, we are going to say x, let's do it this way rather. Let's say, so in the third quadrant, it's 180 plus the reference angle. And for the fourth quadrant, we'll say, fourth quadrant, 360 minus the reference angle. Okay, so the negative comes in when we do our quadrants and to help us find our final solution. So that gives me 180 plus 16.2 is 196.2. And 360 minus 16.2 gives me 343.8. So therefore we can end off and say x is 196.20 or 343.8. So we're still just working between 0 and 360. So that's why we're getting those two answers. We're just doing them in the two quadrants where sign is negative. Okay, I'm going to leave you to it to find this third one. I'm going to give you 5 minutes to do that, maybe less. Let me go over here.
Yeah, I think less, Ms. Barnard. They're really good at this, so I think they're going to get it quick.
You think less? Okay.
Yeah.
Okay, let's do 2 minutes. Let's go.
Yeah, that sounds great.
Okay, so solve that one for x between 0 and 360. Remember to pop your answer in the chat when you're ready. Well done, Oratilwe and Nao and Taylor. Looks like we've got our answers here. I'll give 30 more seconds for anyone else who wants to throw in an answer. Or if you agree with what they're getting, then just put a thumbs up. Can also do that. Okay, we are getting slightly different answers. Okay, let's have a look. So we start off dividing by the 3 first. So tan of x will give me negative 2,451,3 with a few decimal places after that. So we're going to ignore the negative and just put into our calculator shift tan to get our reference angle. So shift tan of that number, that gives me 67.81 degrees. Now we're going to get our quadrants by checking where tan is negative. So tan is negative in the 2nd and the 4th quadrants. And to get our 2nd quadrant angle, we need to subtract the 67.81 from 180. So 180 minus 67.81. That gives me 112.19 degrees. Well done. There's a few of you who got that. Yes, now just follow 2 decimal places as a rule, unless you are told to do it differently in the question. And then 360 minus 67.81 gives me 292.19. So our 2x values is 112.19 and 292.19. Okay, interesting numbers. All the numbers are in the, yeah, they repeat, but just in a different order. So King Zooks, we are not doing general solutions yet. We are going to get there very quickly. So stick around, watch the space. We are heading our way to general solution. Okay, let's do this last one, question 4. And I think this time I'm giving 2 minutes for this one. There we go. Question 4. Well, it now says question 1. Let me just fix that numbering. Question 4. 2 minutes, and put your answer in the chat when you're ready. So, Nati, to answer your question, when we find the reference angle, we are just looking at the positive value. And when we do our negative, when we do our quadrants, that's when we look at the quadrants. So I hope that answers your question. I think if you put 292.19, so tan of 292.19 into your calculator, you'll see that it does come out as negative 2.45. Musa, we are not going to do it in this course. It will be a separate course on trig in 2D and 3D. When we get there, probably a bit later in the year, probably in term 3. If you are solving question 4, remember to get the trig ratio by itself first, because the calculator will likely give you an error if you haven't done that. So make sure you have trig ratio equal to a number, like I've explained over here at the beginning of the lesson. It must always look like that. Trig ratio, angle equals value. That should put you on the path of finding the right solution. Okay, answers are in. Gonna give a second for a few more answers. Okay, so 2 sine x. I'm going to take the negative 4 over to the other side first. So negative 5.25 plus 4 will give me negative 1.25. Okay, more answers coming in. Great. Please keep them coming as I start solving this. So then sine of x, we need to still divide by 2. That gives me 0, negative 0.625. Okay, we can already do quadrants. Sine is negative in the third and the fourth. And our reference angle is going to be shift sine 0.625. And that gives me 38.68 degrees. So we can do our third quadrant answer. Third quadrant answer is 180 plus 38.68 degrees. And we'll work that out just now. And my fourth quadrant answer will be 360 minus the reference angle, 38.68. So 180 plus 38.68 is 218.68. I see many of you agree with me. And then the 360 minus 38.68 is 321.32. Okay. Wonderful. Well done to everybody who tried it and who got those answers. That is really good. Yeah, so we've got a few more that we can practice. Let's do these last 2 questions. Where it says your turn, solve the following equations. So we're going to take about 5 minutes. I think that's also enough for us to do these 2. And then we are going to probably end off with a poll. So let's give these last 2 questions a shot, and then we'll see how we go. Okay. There's a question here. I don't understand the positive. I'm not sure what you mean with the positive, Murungoa. Positive. I'm thinking that maybe you mean why do we just put in 0.625 and we ignore the sign at the beginning, because we are looking for this acute angle. Okay, we don't want a negative angle. So if you go shift sign 0.625 into your calculator, and you make it negative, you'll see it brings out a negative angle. We don't want to work with a negative angle, so we just ignore the sign when we do the reference angle to get the acute angle. Okay, and you're always going to do that when you find the reference angle. Sorry, I'm going back to the way the questions were. There they are. And we'll check back in a few minutes for everyone to be done. Please pop your answers in the chat as soon as you're ready. Nati's asking why is sine positive in 180 and tan is negative in 180. Nati, we did cover the Cartesian plane in quite a lot of detail a few lessons back, and it basically has to do with the different values for sine, cos, and tan in each quadrant as we move through the Cartesian plane. So please feel free to rewatch. It's probably lesson 2 and lesson 3 where we look at the Cartesian plane, and you'll see that I give quite a lot of a detailed description there of why sine is positive and why tan is negative in the different quadrants. Remember, guys, we are doing it for x being between 0 and 360. So you should get 2 values. I assume that's your reference angle. Yes, now it looks like you're on the right track. You should have 2 values for tan. Okay, answers are starting to come in for this first question. So let's have a look. To get theta, we need to divide by 3 right through. So then theta is 25,65 degrees. So that's our reference angle. We are now going to look at our quadrants. Our quadrants, tan is positive in the first quadrant and in the third quadrant. So our first quadrant answer we already know is just going to be the actual acute angle, 25.65. So our other answer will be 180 plus 25.65. And that gives me 180 plus 25.65, 205,65. If you are getting, if you're not getting that, you probably forgot to divide by 3. That's probably the most common mistake. Not sure how everyone's getting 64.55. Remember, in the first quadrant, we don't have to go 90 minus, okay? We don't have to do that. It's not necessary. We just work with the acute angle as it is in the first quadrant, okay? And then in the third quadrant, we add it to 180. Okay, and for this, you should have 2 answers, okay? Not just one. You need to have the 25.65 and the 205.65. I'm not sure, Taylor, how you got that answer, the 152 and 208. It's, I think there's a mistake somewhere that you just need to correct. And I keep seeing the 64.55. If you got 64.55 in your first quadrant, you went 90 minus. No need to do that, guys. No need to subtract it from 90 in the first quadrant. You only do that when you're working with co-ratios, and we don't have to introduce co-ratios if we don't have to. So just stick to the acute angle. It's already acute. We don't have to change it. Okay, last one. For this evening, we are going to do cos theta minus 27. I think we've got about 2 minutes for this one, and pop your answer in the chat when you're Nati, I think you need to check your quadrants. Tan is positive in the first quadrant and in the third quadrant, not in the other quadrants. So that's why I think you're not getting the answer we're getting. Please check that you worked in the right quadrants. Just checking some more answers here and giving some feedback. Okay, people are already putting in answers for this last question. Okay, looks like we're ready. Hey, Miss Coco, these guys are working fast this evening. Okay, so be careful here. We have a negative. We're only going to use that negative at the end. And our trig equations already in the format it should be. We've got trig ratio and angle equal to number. So no further work needed, straight to reference angle. So we can say shift cos 0.75. And again, we only do the positive, not the negative. We're going to do the negative when we decide on our quadrants. So theta minus 27 is 41. Sorry, I'm writing 14 instead of 41. 41,41. We need theta, not theta minus 27, so we add 27 on both sides. That gives me 68,41 degrees. Okay, now I'm going to decide on my quadrants because I'm working between 0 and 360. Cos is negative in this quadrant, the second quadrant, and the third quadrant. So my first quadrant answer is going to be, my second quadrant answer is going to be 180 minus my reference angle, 68,41. So 180 minus 68.41, that gives me 111,59. Okay, so if you got that, well done. And then my third one is 180 plus 68,41. Okay, answers coming in the chat. Well done, everyone. Well done for trying, and don't give up. Just keep trying. 248,41. Now, I saw quite a few people get that. 248,41 degrees. So those are your two answers, 11,59 and 248,41. Okay, I see some different ones. If you got something different to that, I don't think either your quadrants are wrong or your reference angle is wrong. Your reference angle must be 68,41. This one here. Okay, so check that you got your reference angle correct. Once you have your reference angle correct, check that your quadrants are correct, that you've worked in the second and the third quadrant, because that is where cos is negative. Okay. I see some variation in answers here, but guys, the only answers that are correct are these two. And like I said, if you didn't get that, check that your reference angle is correct and your quadrants are correct. If we get a negative question, our quadrants must be negative as well. Yes, that's a good summary of it, Riyadh. That's it. But we never work with a negative angle. We always work with a positive reference angle. Okay. Right, we are almost out of time. So on Thursday, stay tuned. We're going to do general solution. So this is our warm-up lesson towards general solution. Some of you asked about this, and we will definitely do that on Thursday along with our quiz. And I think, Ms. Coco, that's it from me. Ms. Coco is going to launch the poll quickly. Yes. And you ready, Ms. Coco, with the poll?
I am ready, guys. Just look out for something that's going to pop up on your screen now. All you have to do is give me one answer. You just have to pick one or the other. And while we're busy with that, Leroy is asking, why don't we say 270 minus for the third quadrant instead of 180 plus? Will it change the answer?
Sorry, I didn't see that. Ms. Coco, did someone ask that?
Yes, in a DM. He says, why don't we say 270 minus for the third quadrant instead of 180 plus? Will it change the answer?
Yes, because 270 and 90 has to do with complementary angles, and then we have to shift to co-functions and co-ratios when we work with 270 and 90 minus or 90 plus, and therefore it is better to just stick to theta, 180 minus, 180 plus, and 360 minus. There's only one instance where we are going to use co-ratios, and that I'll cover in the next lesson. But other than that, don't complicate things by using 90 minus, 90 plus, or 270 plus and minus, okay? Just stick to those original quadrants.
All right, thank you very much, ma'am.
You're
yeah,
welcome.
I'm waiting for exactly 3 more people to give me answers who haven't, but I'm going to stop the poll in a bit. Yeah, but we are getting some really good questions. I'm going to end the poll now. Thank you guys so much for that. And with that, we do have a couple more questions in the chat, but I'm unfortunately going to have to run off to the grade 10 class. So I will see you later, Ms. Barnard.
Okay. Thanks, Ms. Coco.
Thanks so much, guys. Bye. See you guys.
Bye-bye. Okay, I'll quickly answer. We've got about 2 minutes left, and I'll answer the last questions. It seems like we are dealing with reference angle. If you may, please explain the difference, ma'am. The difference, I'm not sure the difference between reference angles and what else. Lolita, maybe just rephrase your question. And we should only round off on the last step, right? Because it gives an inaccurate. You can round off your reference angle. That's fine. Will our answers be wrong if we don't round off decimals? Yes, Rihard, you need to round accurately to 2 decimal places. At the end of the year, they do penalize for rounding, and they only decide that when they are basically setting the memo for the paper where the rounding penalizes. So you never know where it's going to be. So learn to round off correctly to 2 decimal places. Okay. Thanks, everybody. We've got 1 more minute, and then we've got to go. When I tried to get cos to the other side on the last equation, I got, instead of 68.41, what did I do wrong? Nati, you're not getting cos to the other side. Just be careful with exactly what it is that you're doing. You are finding the reference angle. Just look at your steps again, work through those steps over there that I've put up just now, and you should be able to see how to get to the answer. Okay, so you're not putting cos on the other side, you are just going shift cos 0.75. The difference between what we have been doing, ma'am, and general solution. No, there's no difference. These things are related. Remember, this is the beginning. This is preparing us for general solution. You'll see in our next lesson, when we do general solution, how this is related. Ma'am, are we going to be dealing with more of the metric work? So this is foundations of trigonometry. Like I've explained a few times. In this course, we cover the basic ideas that you probably missed out on because of missing school a lot last year and school closures, etc. So we are covering the basic ideas to prepare you for the grade 12 trigonometry. Okay, so Kezia, the quadrants, how to see which is negative and positive, that comes from CAST, your CAST diagram, or all stations to Cape Town. It is probably in lesson 2 and 3. I think we covered that. Okay, guys, we are out of time. Thanks so much. I'll see you again on Thursday. Bye.